So Kamiwaza, I'm not trying to win the coolest name award for a company. It actually has sort of a deep meaning. In Japanese, like a lot of awesome Japanese words, it's hard to translate into English. It can mean anything from divine skill, godlike, and then in business context, it's typically superhuman. So that's obviously what we're sort of grabbing onto. So not only is it a cool name, it was in a great book called The Icarus Deception. They talk about sort of living and being Kamiwaza. And it just also happens to be the name of one of my favorite games growing up, Kamiwaza Art of the Thief. I love throwing that one in. So Matt and I co-founded it. Matt's on Zoom here. He's going to be showing some of the live demos. Yep, there he is. And we sort of have a history of long history together. This is our second company. It was CTO at my previous company. So we've really hit the ground running, and we're pretty excited what we can show off here today. So I watched yesterday. There was a lot of talk from several of the companies about training and inferencing. The focus today and the focus of our technology is really going to be on inferencing, or the operations of generative AI. So I always like to set the stage a little bit. Simple chatbots, it's typically about 2 to 3 inferences per request, where it actually has to scan back and forth over the model to actually get a response. This is your typical ChatGPT one shot. You're just sort of throwing something into a chat interface. Then you escalate pretty quickly to chat with RAG, retrieval-augmented generation. It immediately sort of jumps up from an inference, from a load perspective, pretty darn quick. So you go from about 2 to 3 to now 5 to 30 inferences to actually cover the retrieval of the data, the re-ranking of the data, the ingestion of the data, the processing of it, and then actually pull that back in. Now, the reason I'm building this up is because what we're going to focus on today is agents. That's really sort of the buzzword, but it's actually what sort of our customers and typical outcomes are being built around. So an agent takes this to a whole other stigma. Now, for a simple agent request that you sort of tell it to go autonomously accomplish something, the inference load goes through the roof. Now it's not just sort of 2 or 3 or 5 or 10. You're talking a minimum typically of 100 inferences. Real agents that run real autonomous and are doing real data processing can get into the 10,000 plus inferences just to accomplish a simple sort of request that you would give an agent to go accomplish. Add on to the fact that each one of those inference requests might have a data request associated through the RAG process. You might be looking at anywhere between 1,000 to 10,000 to 100,000 data pools, actually pulling that data, having the model ingest it. So a simple agentic request can kick off massive amounts of compute and masses, and I mean masses amounts of data ingest, pulling, copying, reading, etc. And this is why we come up with the concept of data has gravity. I love this quote from my good friend Michael here. AI inference and data gravity is going to drive sort of the idea of repatriation. The load that it's going to be required to run these agentic workloads needs, because of the speed of latency, the actual amount of data that they're ingesting, to be processed next to that data. This is actually one of the biggest inhibitors in enterprises' adoption of Gen AI. Think about it. If their data spread across cloud, prem, edge, multiple clouds, multiple databases in the clouds, multiple data services like Snowflake and Databricks, and a simple agentic service to get an answer has to touch multiple data pools in multiple locations, it's nearly impossible for the enterprise to actually stitch all that together or to move all of that data into one location where the inference engine can actually attach to it to actually run that many pools. And through our research that we ran for about 1.5 years, we saw this as the #1 sort of impediment for the enterprise adoption in generative AI, especially in agentic resources, let alone the security, let alone all of the access controls to all that data when it's spread across all those locations, let alone the pipes, just not having enough bandwidth to actually service them and to connect. So how do you sort of attack what has been a general problem in all of IT infrastructure for the last 30 plus years? Well, we went about it in what we believe are 4 unique ways in the market. And these 4 unique ways in the market is why the Fortune 500 and large government organizations have just been flocking to us. And literally, we're having a hard time keeping up with the ingest of net new customers. So let's go through sort of our quote-unquote 4 major differentiators. Now, once again, we're only talking inference. We're only talking the ability to process and run models, not train models. First, we deliver a full stack for the enterprise in a Docker container. We're not going to talk Kubernetes today. In a Docker container. Those set of Docker containers is the entire opinionated stack for the enterprise. On the next slide, we'll do a deep dive on all of the constructs of that. I'll pass it to Matt to explain the stack in a little bit more detail. We call this, though, our opinionated but loosely coupled stack. And this is also a game changer in the market. So within 15 minutes, the Docker containers can be installed, put on any hardware with a large enough CPU or GPUs to actually run inferencing. It's loosely coupled because the Kamiwaza middleware allows you to swap out all major components of the stack with about one line of code. So if the enterprise doesn't like the Milvus vector database that comes with the opinionated stack, and they want to use enterprise DB, vector DB, it's one line of code to swap that out.
It's not true for, there's a lot more to installing certain vector databases. Like MongoDB would take a whole lot more work than, say, Milvus. Anyway.
No, if they already have that.
One line of code.
If they've already had it, if they've already started down their journey, and they already have a different vector database
already implemented. Okay,
so instead of using our opinionated one, it's one line of code in our middleware to swap out the other one. Okay. Matt, do you actually just want to cover that on how
there's a lot of credentials if they use different.
Matt, you want to just swap on how we abstract the vector database services?
The short answer is we abstract as much as we can. Sometimes if we're talking about things that have like super divergent things, there is more commonality for some than others, and that's true. Okay. And of course, some things like Mongo or PGSQL, PGVex support might contain metadata that you'd want to use that might not be universal, right? So we're normalizing things like collection names and the interface for inserting and retrieving vectors. But you're right. But we try to make it relatively easy to kind of hook in under the scenes. And like a good example is that our default Milvus client, when you're instantiating the Kamiwaza one, the native Milvus client is just not client in our object, right? So we're not trying to like obfuscate things. We're trying to just kind of help you along.
I'm just saying, saying you can do something one line is dangerous in front of a lot of technicians.
I understand. Yep. Second, the loosely coupled architecture also allows us to separate sort of a lot of the dependencies. And the ability to just update those individual dependencies also allows it to be sort of a much lighter load across it all. But once again, fully containerized. Second, and I'm going to combine these two together, it's what we call our inference mesh, our global inference mesh, and our locality-aware data engine. There are two key concepts, and I can take you through the paint by numbers here. So first off, you see the Kamiwaza stack installed in cloud. This cloud is a private cloud for this particular instance. You need access to the underlying GPUs and CPUs. This isn't a SaaS service. Think about, Amazon, Microsoft, Google's private side of the cloud. That cloud can be swapped out for any location. It could be any data center. Cloud's just a representation here. So you have the full stack of containers installed on a GPU-based cluster in the cloud. Then you install the Docker containers on a GPU-based server in the data center. You ride the enterprise networking using Docker Swarm networking. So they connect right over the enterprise network, effectively VXLAN, encrypted, so that the two are now aware of each other. Now, once the two are aware of each other, you get the concept of the inference mesh. The ability for you to move inference load based off of the underlying hardware that it's running on, the models that the individual stacks are running on, and then you add the third component, which is the data component. So as those stacks do their initial RAG or continuous RAG processing, where they're actually building the underlying embeddings and putting those embeddings into the vector database, we add layers of metadata and put those into our own global catalog service. The global catalog service is then shared between the two clusters, so the individual clusters know not only what data they could actually process in the RAG, but they have the affinity of the location tied to the actual Docker container that did the processing. Now let's go through the paint by numbers on why that's so important. As a request to our stack happens, substantiated from an LLM-enabled app or a user service, it hits our stack. The LLM on our stack says, I need a RAG data to resolve this particular request. But in this case, the data for the RAG requires data from both the cloud and data that resides in the data center. So it kicks off through the paint by numbers here, now number 3, and is running the RAG process in the cloud with the data that resides in the cloud, while simultaneously kicking off an inference request to the data stack that's running in the data center. The stack in the data center realizes then it needs to run the RAG process with the data in the data center, and then it only sends the inferred result tokens back to the initiating stack in the cloud. There, it concatenates the result and gives a single response back to the user or the application that actually hit it. In doing this, we've effectively split the data gravity paradigm because we've actually processed all the data local and only sent back the actual result tokens between the two. These tokens could have been sent over a dial-up line, a 28K modem, literally could have moved them. We're talking very, very finite little amounts of data. And in processing this, we've gone through, because that RAG process isn't as simple as just a process. As I pointed out with the agent service, it could be 5,000, 10,000. It could just constantly be processing, reprocessing, re-ranking, and rerunning that data in that location. But once it gets the result, it actually sends it back. That way, once again, we haven't had to move the data beyond the firewalls of the enterprise. We haven't actually decided to move too much data. Our customers are typically in the petabyte, exabyte scale arena, and this allows the inferencing. Now take it to the next level. Multiple clouds, multiple edge locations, multiple data centers across the world with GDPR and HIPAA. This is a way to process and run generative AI solutions through all of those major paradigms.
You think splitting up the inferencing GPU side of thing versus the RAG thing is going to add more effectivity or less data transfer? I'm trying to understand why you did this.
I think mostly data sovereignty. Yeah. I mean, yes.
But the tokens are still being passed into the cloud, right? And then with the tokens, you could potentially reconstruct some portion of the data with the appropriate LLM. I mean,
no, right? We're talking processing million genomic sequences locally and then only sending back the results saying 5 genomes were actually having this particular marker would be the tokens that actually pass back. Nothing in the actual genome sequence. I'm just giving you a concept of an idea.
Right.
You can further have obfuscated rules where you don't pass 5 data, you don't pass 7-digit numbers between those two stacks. There's multiple ways to work around that.
To secure the data.
A lot of the functions around LLMs feel to me like MapReduce operations. And so, Luke and I in past lives have had customers that had as much as 750 petabytes of data in their, call it data lake, although it's never one data lake at that size, right? And so we were definitely thinking about how you deal with that and the concept of, if I have 22 global data centers and I want to say, find me every customer service record, from a customer service call log where XYZ happens. And in every event, you're essentially going to pull every single customer call transcript. You're going to have many, many inference passes against that, right? Because you can't just dump them all into a model and go, tell me this thing, right? You need to do some level of entity extraction and organization on the transcript. And then each of those results in multiple calls. Now, gravity starts to help there. But then also, of course, when data sovereignty comes into play and you're saying, well, the things from Germany, we have to keep in Germany. That's the second big reason.
But if it's all coming from the RAG, right? Then do you have to have sovereignty per RAG, or do you have to have bifurcation for RAGs for different vector databases, and then you get into vector database sprawl?
Thank you. Yeah, it's well, of course, at very large scale, you're using many vector databases anyways, because there's a limit to how many vectors you're going to store. And think 750 petabytes of data. I don't think anybody's going to vectorize all of that.
No, they won't. Yeah,
but you get massive amounts of vectors nonetheless. In this case, what we're doing at our layer to be a little bit more in the weeds about how it works is we have a catalog layer that comes with Kamiwaza. We'll see it in some of the demos. When people do global clusters, we can interlink the catalog because we're only really tracking metadata, right? We don't keep data itself. And even if you put data in the vector database, that's local to whatever vector database you're targeting. But with the metadata and our awareness of location, we can essentially say, well, the person wants to use all the catalogs that match this pattern, and therefore we can essentially remote across the interlink, the intercluster communication coming. As I say, we're going to run this here and there. To try to draw an analogy, it looks a bit like a DAG execution, right? You're running, you're distributing functions basically to do this in every location. Each location retrieves the data that's associated with its local version of the catalog. You know where to send those requests because the metadata about the catalog is globalized, but you're sending it to each location, doing the RAG in each location, getting some level of local inferencing, although you can move data, by the way. It's not a hard and fast rule, right? But the main idea of the feature is you're going to do it locally. But then you can coalesce all the results back. And I think of it a little bit like, to do another analogy, I think everybody here is probably familiar with Starburst, for example, right? And Presto and Trino and Starburst are all essentially distributed Hive SQL type query engines. The trick about Starburst is they can actually be multi-site and like distribute the query in many places and do like predicate push down to kind of optimize some of that. Right, we're doing something very similar with the catalog.
So Matt, just hi by the way, but
hey.
So what you're saying is sort of a data gravity for RAGs.
For sure.
Okay, all right. That makes a little more sense. Okay,
RAG per site because of data gravity.
Yeah, got it. Got it. No, okay, all right, makes sense.
But to challenge to some extent, agent, you mentioned this earlier, is that agent workloads are doing literally thousands of inferences, which is
each inference can have hundreds.
Yeah, each of those is potentially another RAG operation. I mean, it's a lot of interaction between these two clusters that are going on in order to support this agentic workload. Is it?
They're bifurcated.
Think about site A goes out to site B and C, and site A is doing it itself, and it says to each one, "Hey, for catalog items like this that you have locally, go retrieve them, and then pass them into this inference process." Right? The inference process is done over Ray using distributed remote functions. Right? So it's a little bit like executing a remote Lambda that we just make a little bit easier. In each site, it is locally responsible, and this is all happens simultaneously for retrieving the data in that site, processing with the language models deployed in that site, and then you can refederate all the kind of final answers, if you will, at the bottom of that MapReduce process back to the middle. Does that make more sense?
The true key is the processing is local.
Between the data source and the LLM in general.
Yeah. Still not clear to me that you're buying much by segregating the RAG process from the inferencing itself, but
the inferencing is local to the RAG and is running. It's not separated. It's running there.
But you're passing the RAG information.
We're not passing the RAG information.
Not passing the RAG.
Only the result of all of the inference and all of the RAG processing. Only
that wasn't obvious. I thought we were actually
no.
passing the tokenized RAG.
No, I'm trying to like beat this into you. Only that result. That's why it's so important. You're not moving that data. You're not exposing it. It's only that result after all of that is run locally.
And I think in practice, of course, like this tends to be less about performance and data gravity, just because of how heavyweight LLM processes are in general, much more about sovereignty. And then you can actually implement things like guardrails. So it's very common practice now for production scale RAG or production level RAG to be doing things before responses come out, like cross-check them with another model and another process for things like getting PHI and PII when you don't want it, right? And so you can do that per site, which helps deal with compliance challenges.
How are you dealing with a lot of changes in RAG right now? You got CAG, you got graphic RAG, you got agentic RAG, and it seems like it could get a little complicated for you guys to approach that you have.
That is a great question. And so what I'd say is the methodology for doing the RAG is decoupled from the theory of the inference mesh and the distributed data engine. So that pattern, but we do actually supply some middleware that kind of helps with RAG, and we are in the middle of a pretty substantial revamp because we want to actually make a lot of the point of the middleware that we have, beyond like what Kamiwaza does operationally, is to make development of these things at the app layer much easier. And so we're definitely pulling a lot of those things in around graph RAG, enabling things like doc ETL in pipelines. If there's a fantastic paper about using models to basically enrich the metadata that you use for embeddings that Anthropic published, right? Allowing people to easily turn up like model LLM-based enrichment pipelines, things like that. So yeah, it's a pretty big deal, but it will fit into the inference mesh pretty easily.
Cool.
And I'll say that's part of the loosely coupled aspect of this. If they had a graph rag service that they've already wanted, or they want to inject a graph rag service, once again, our middleware will just point over to that, and they can take it over.
But not one line of code.
Several at that point, yes, obviously.
Sorry.
No bother. But our opinionated is sort of, and then our next rev, like Matt's talking about, we're actually going to add that feature into our opinionated one on the next.
You had me at loosely opinionated. That's really good architecture.
So I know Kamiwaza is a relatively new company. There's obviously the big ones folks would have heard of, like you could say Snowflake, you could say Databricks, but then there was also like Starburst, also a fairly young company. You could probably say ClickHouse. You could probably say OneHouse. All these other kinds of hybrid data lake kind of approaches. Do you separate there are certainly these hybrid data lake companies. Where is the Kamiwaza differentiator that you see as compared to, say, like someone that's shipping a solution set for the hybrid data lake problem versus the one that you're referring to, which is kind of when agentic happens, you're sending all your fastest ships, but only bring the results back that matter. Don't bring the entire landmass of America once you've discovered it, for example.
Yep.
Okay.
But keep in mind, a lot of those you just talked about are structured data services. We're any data service.
So you're
we connect to anything: raw PDFs, Word documents, file services, BMP files. We're going to talk about those on weather mapping services. Anything that AI can attach to.
So you can do the WINs. You can do words, images, numbers, sounds.
It's getting incredible, and you don't have to put it into structured format services. Of course, you can. You can have it in SQL. You could have it in Parquet tables. You can mix and match all of that, and that is what our customers are starting to utilize. The fact that they could be in Azure, install our stack, connect to a Snowflake instance, connect to the Databricks instance, also have their on-prem data that's sitting on their file service, all in the RAG process, all in the agentic flow, is why you get outcomes that are outsized for the market. If you just have an AI service that is just running in a data lake service, like a Snowflake or a Databricks, but you need data that's outside of that to complete even 5 or 10% of that request, that means you have 5 or 10% information missing because those AI agents don't reach into it, and you actually can't run that process. You don't get the value, you don't get the actual output that's needed for that.
Okay, and that, I know you said loosely couple, and you talk about swapping, but I'm also hearing you say that you can compose differently as to what you're trying to achieve. So if it is, cloud service A, cloud service B, and then some on-premises enterprise instantiation of a OLAP or whatever it might have been, you can have those catalogs seen globally to assemble for the outcome you're trying to achieve.
Our inference mesh understands the global catalog of all of the data. Right. You mentioned OLAB. You would probably swap that out for the Kamiwaza stack.
Okay.
Where the enterprise.
So if I paint an enterprise architectural diagram, and I'm going to rip something out, and I'm going to replace it with something, your position would be as if there's an OLAP appearing on that diagram, Kamiwaza would attack that OLAP space.
OLAP.
Yeah.
OLAP.
Matt, do you want to cover that? Because I was thinking of llama.
Yeah, I mean, honestly, the use case hasn't come up. And it's for me, I think you probably have to tell me, Jay, like, how are you picturing, like, the LLM models being involved in the OLAP processing? Like, we do a lot of things. A common customer use case when it comes to, like, anything that looks like data warehousing or general analytics is they tend to get LLMs involved a lot in kind of the ETL pipeline, ELT pipeline, right? One way or the other, right? They're kind of cleansing of data, transforming it. And one of those things that's really marvelous, and I'll pontificate for a second, right? Because I think this is valuable for everybody to hear, is the sort of non-deterministic nature of LLMs makes them fantastic, right? If I told you to write code and I said, I want it to correct typos, you would have to laugh at me because you'd be picturing like hundreds of thousands of lines of code and it would still be buggy and not work, right? And language models just get to do that, right? That's the kind of power of the fuzziness of neural networks and transformers. And self-attention in general is they deal with those abstractions, which makes them great for data cleaning and sort of recognition of things. And the other thing, and I actually do have a demo. It's the only one I'm not going to do live because I just don't have, it's hard to do the environment, but I'll run it for you, which is actually LLM-driven data analytics, where you kind of either take a data set and you let a language model kind of construct queries and stuff. Right? And in our demo, we'll show you, we actually, we have a query running with DuckDB against backend Parquet files, and we give it like a natural language prompt, and based on that, the model actually reconstructs both the SQL query and it rewrites the React component to render it to the instructions, which is pretty cool, right? That's a good idea, maybe, of how you're thinking about OLAP, but some of that stuff ranges from like baby steps to industrial. And so I think we'd have to know a lot more about the scale and the use case to really answer the question.
Yeah. That's helpful because I was thinking it was displacement, but now what I'm hearing is the OLAP might just be simply one of the other go off and run this query locally,
augmentations,
and the computation comes back. Okay. Thank you.
So the last bullet,
write me code to run a query, right? I mean, a funny thing is, we're certainly living in this world where everybody just can and will throw more compute at everything. This is one of the reasons why obviously NVIDIA is being hugely successful. But it's very easy and you'll get a hint for this from our other demos, which are completely, I mean, some of these are a little off the wall, like how wild agents get. But the fact that you can just go and ask for data and it'll build a whole pipeline for you. I mean, in fact, I can't show this right because it was done for a customer, but you can go see this discussion, this panel where the chief meteorologist of the DHS was talking about the work we did to extract weather data from some horrible, like, kind of ancient format called Genpack and convert it to Parquet. And that ultimately was done by an agent. So I can't show you that work, but I will show you the agent working today. And when you start to realize, wow, this thing can like actually just go and autonomously convert things, you start to get ideas about like, well, what can I do really, right? And you combine that with like models like Tab PFN, which recently got released, that actually uses a transformer to do the equivalent of like logistic regression models, but except you don't train them. You just pass it the entire, what would have been your training set essentially as data, and it instantly infers a correct answer. And it performs better than models that are trained for 4 hours. So I mean, yes, you can tune it at some point, but it's wild that you can do that now. Neural networks being applied directly to, analytics questions, right? And that kind of analytics thing used to be much more the classic predictive analytics models and not the LLM domain. And now you see this like transformer architecture actually bridging those worlds.
So that fourth bullet on the other slide of our differentiation is the fact that this is entirely silicon agnostic. So as we're going to show in a lot of our demos and services today, we'll be doing some of the processing on AMD, some of the processing on NVIDIA. It could also run on a Mac. So our community edition, our free developer level edition, works on any Mac Metal and above. This laptop here has a Lunar Lake processor. It runs just fine on that. The new Strix points from AMD. Maybe you want to get into more discrete level stuff like Qualcomm processors. The point of that silicon agnostic approach means that at the edge, we can be put on the right hardware. At the data center, we can be put on the right hardware. And then the cloud, we can be put on the right hardware. The new ARM chips and inferencing technology coming from Amazon, not Intel, obviously. The Inference chips, the Tensor chips over at Google. This agnostic approach allows us to literally run where it needs to on the right price, on the right concept, on the right scale, cloud, prem, and edge. So that opens up sort of that paradigm. But then you have the ability, once again, this is the full stack view. It's quite large. It's 150 plus packages. But I just want to take the one step back on where this really goes and what the tagline over the slide says. If we connect to all of the data of the enterprise in all of its locations and all of its forms, if we are running across cloud, prem, and edge, we are connected to all of the security constructs of the enterprise, the SSO and SAML authentication structures for the LLMs and the users that are accessing that data. And we've federated that, and we're running that dispersed across the entire estate of the enterprise. It's not just our apps that customers build and run on Kamiwaza. It's also all of the third-party and ecosystem apps that you simply plug right on top of Kamiwaza. We then become, and it's a concept I literally built for this room, sort of the Docker for generative AI, because now you're talking all of these third-party apps simply plug into us and get that access.
Just so I understand this correctly, right? So you're both a RAG inference aggregator for gravity and data, which locality, all that stuff. But are you also helping build the RAGs as well?
Matt's going to.
I mean, I just wanted to know.
Yeah, like going to show you
like DataWorks would be
process through the Python.
Okay, I was trying to say.
But you don't have to do that. Once again, loose couples, you can pick whatever. But yes, we honestly do.
But the point being, like, you look at a company like DataWorks.
Yeah.
Right. That's their argument, that they can take anything everywhere and RAG it.
Mm-hmm.
So that's you're in that business as well.
We're in the business of enabling that.
Okay.
And doing it if you want.
We're very much not SaaS, right?
No, I know that.
There's certainly tons of products that are sort of like use case specific, right? And of course, I mean, one of the problems is they're actually almost all delivered as SaaS. And so if you have anything you want to do, and by the way, I mean, this is not foreign. This is everybody. If you want to do something with private, secure data that you don't want to put out in the SaaS API, and I mean, it's really timely, right? Like just this morning, we saw this news about DeepSeek getting breached. A bunch of their prompt and user data is just like completely leaked out in the public through some backdoor, right? I expect that's going to have fallout, in this direction, right? Because it's kind of first major service leak I think I've seen like that from a model provider in that way. And it's a great example of like why I think enterprises and the thesis at them, it's not that they're necessarily negative about generative AI, but they're negative about shoving data into random generative AI services, especially because to your point about young companies earlier, a lot of young companies, and keeping that stuff in the four walls can be very reassuring.
So the catalog becomes all important in all this discussion because that's where the enterprise data resides. And so I'm trying to understand. So it's almost like you're parsing out the agentic workflow into various interface RAG interactions and divvying them out to wherever those interface nodes in your interface mesh actually have access to that data. Is that what you're doing?
Yeah, absolutely. Locally, it accesses that data using the enterprise security. It has to.
But how do you know?
It's got to pull that in to actually inference.
How do you get to a point where the agentic workflow is parsed out and to a point where you know actually what data is required for a particular request?
Well,
yeah. Go ahead, Matt.
Okay. So if you start thinking about agents, like really agents are almost like programs, right? They're kind of comprised of widgets, and you can have multiples, and they can interact through interfaces where they're not aware of each other. People can build them on top of frameworks like AG2 is a good example, right? Formerly known as AutoGen. They're off doing a new version commercially now. If you think about those things, every one of those agents basically tends to have some mix of prompts, input, tools, those sorts of things. So with us, you can give them access to go read the Kamiwaza catalog, but there's the question of what kind of credentials they have or what kind of access they have, right? So you, through our system, can give an agent access to as much data as you have access to, right? Through a role. You can also create roles that have less access and give it to the agent. And now, critically, we're mindful of the fact that some things are deployed to act on your behalf, Mr. User A, but also some things are things that you deploy to act on behalf of other users where it should actually have their permissions, right? And this is actually a really critical aspect of the things that we're doing because we've built basically local auth and JWT enforcement at the edge and awareness of these things at a catalog layer, so that you can actually take whether it's local identity, OAuth identity, SAML identity, right? Identity is one layer, and then the kind of access controls flow from there. And then anybody can kind of pass them to applications and agents that leverage our stack. And we put a blog up entry on one of our GitHub docs site about 2 weeks ago that shows about 20 or 30 lines of code you can use, both all on the front end. We actually integrate an app directly with Kamiwaza's authentication and with our model repository, right? So you can actually build a completely private Gen AI powered application that then actually benefits from our implementation of that identity enforcement, and we pass that to the catalog.
And Matt's going to show this, but and I didn't cover it. The stack is forward presenting everything via an API. We have our own SDK as well. We have one API that is literally across the entire data state for this power, for this inferencing.